Today we're going to talk about a hot topic in JavaScript, regular functions versus arrow functions. Strap in and let's get started. On the left side of our screen, we have a regular function. This traditional way of writing functions has been around since the early days of JavaScript. Here we declare a function named greet using the function keyword. We pass it a single parameter, name, and in the body of the function, we're returning a personalized greeting. Notice how we call greet Alice, and it gracefully responds with hello Alice. Regular functions like this can be hoisted, meaning they can be called before they're even declared in your code. Handy, right? Now let's slide to the right and introduce the sleek arrow function. Arrow functions were added in ES6, offering a more modern and concise way to write function expressions. In this example, we assign an arrow function to the constant greet. The parameters go in parentheses, and the arrow points us to the function body. Here, we don't even need curly braces or a return statement for our single-line expression. It's all taken care of implicitly. When we call greet Bob, it echoes back, "Hello, Bob." Arrow functions are anonymous and are a go-to choice for short, temporary functions, especially as callbacks. However, they're not hoisted, which means you cannot call them before they are defined. As we move forward, we're going to dissect the use of this in a series of examples. Each example will build on your understanding, so let's jump right in and talk about our first case using traditional functions. In a traditional function, this refers to the context in which the function is called, which can be different each time the function is invoked. Discussing our first example, here we have a simple function named showName, and then we have two objects, person1 and person2. Each object has a name and a method speak that points to our showName function. When we invoke speak on person1, this within showName refers to person1. Likewise, when called on person2, this refers to person2. The output confirms this behavior. For our second example, let's see how this works within an event handler. In this event handler, this refers to the element that the event is acting upon, in this case, our button. So when the button is clicked, this .text content outputs click me. Stepping into our first example within arrow functions, we're going to decipher how this behaves differently here than it does in traditional functions. Let's begin by looking at an object. First, we have an object named person. It has a single property, name, which is set to Charlie. Now we're going to add a method called speakToOurPerson object, but this time it's an arrow function. The speak method is designed to log the name property to the console. However, since speak is an arrow function, it handles this differently. Let's see what happens when we invoke person.speak. When we call person.speak, you might expect to see Charlie logged to the console. Instead, we get undefined. That's because arrow functions don't bind their own this. They inherit this from the surrounding execution context. In a browser, if we're not in strict mode, this would refer to the global window object, which doesn't have a name property. For our second example with an arrow function, let's revisit the familiar button and its event handler. First, we create a button element, give it some text, and append it to the document body. Next, we'll add an event listener to the button. This event listener will be triggered when the button is clicked. We attach an arrow function to the click event that attempts to log this .text content. Now let's click the button and see what gets logged. Upon clicking the button, we see undefined log to the console, not click me as we saw with the traditional function. The reason is that arrow functions close over the value of this from the surrounding lexical scope. In this context, this does not refer to the button, but to the lexical scope in which the arrow function was defined, which does not have a text content property. Let's dive into another important distinction between traditional and arrow functions: the handling of parameters and the argument's object. Starting with traditional functions, let's examine how they deal with parameters. First, we have a function named sum. This function doesn't declare any formal parameters, yet it's capable of adding together any number of arguments passed to it. The magic here lies in the argument's object. This special object is available within traditional functions, allowing access to all the arguments passed to the function. Now we'll see the function in action, calling sum1, 2, 3 logs 6 to the console. The function iterates over each argument using the argument's object and calculates the total. Transitioning to arrow functions, let's see how they handle the same task without the argument's object. Here we have an arrow function also named sum. Instead of relying on the arguments object, we use REST parameters to gather all arguments into an array called args. The args array now contains all the arguments passed to the function. We then use the reduce method to sum up these values. Let's invoke this function and see the result. When we call sum1, 2, 3, it also returns 6. REST parameters allow us to handle an indefinite number of arguments in arrow functions, effectively replacing the argument's object. Now we discuss our next topic, function constructors and how they differ when using traditional functions versus arrow functions. This comparison is crucial, especially when dealing with object-oriented JavaScript. Let's start by delving into a function constructor example using a traditional function. First up, we have a traditional function named car. This isn't just any function. It's designed to be a constructor, a blueprint for creating new objects of a particular type. In this code, car takes two arguments, make and model, and assigns them to the new object's properties using the this keyword. We also extend the car prototype by adding a display method. Next, we create a new instance of car named mycar and pass in Toyota and Corolla as arguments. When we call mycar.display, we see the expected output, Toyota Corolla. The traditional function constructor works seamlessly to create new object instances. Moving forward, let's see what happens if we attempt to replicate this function constructor using an arrow function. Here, we define a bike arrow function with the intention of using it as a constructor. We then try to create a new instance of bike, just like we did with car. However, JavaScript throws a wrench in our plans. An error is raised when we use the new keyword with bike, which is an arrow function. The error message type error. Bike is not a constructor tells us that arrow functions are fundamentally unsuited to be used as constructors. Unlike traditional functions, they lack a prototype property, which is required for a function to be called with new. Now we will explore return statements in traditional functions compared to arrow functions. This is a key concept that can affect the succinctness and readability of your code. First, let's examine a traditional function that requires an explicit return statement to output a result. In this example, the double function takes a single parameter x and returns the value multiplied by 2. The return keyword is necessary here. Without it, the function would return undefined by default. After we call double with the argument 10, the function returns 20, and we log this value to the console. Let's now turn our attention to an arrow function that utilizes an implicit return, which is a shorthand syntax that allows us to write more concise functions. Here's the triple arrow function. Notice how it takes a single argument and simply states the expression x3 without the return keyword. This is the beauty of arrow functions. When there's only one expression to evaluate, and that expression should be returned, the return statement can be omitted. This only works if the function body is written without curly braces. We invoke triple with 10, and it implicitly returns 30, which we then log to the console. We've seen how traditional and arrow functions handle return statements. Traditional functions always require an explicit return, while arrow functions allow for an implicit return in concise form. Thanks for watching. Don't forget to hit that subscribe button for more videos. See you next time.